This Arduino project turns a couple of buttons and some LEDs into a game. By the end, you know exactly how to make this project. This project isn't actually very difficult to make if you do everything step by step, which I'm going to show you. I'm going to show you the circuit and the code it takes to make this project. So without further ado, let's get started. Now first I want to explain what this project is. It's basically a project that would test your reflexes with two players playing this game, and each player will have their button that they will click as quick as possible. And as they start clicking their buttons, LEDs will start turning on. And the first player that is able to get all of their 8 LEDs on will win. And at the end, the player who won all of their 8 LEDs will flash 10 times. And so that is the project. So now we're going to go ahead and look at how we can connect this project up to the Arduino. Okay, so now here is the circuit. So the first thing we do here is we connect pin 12 to pin 11 on the shift register. And this is shift register number 1. Then pin 11 on the Arduino will go to pin 14 on the shift register number 1. Then pin 8 on the Arduino will be connected to pin 12 on shift register number 1. And then we go ahead and connect pin 10 on the shift register to positive 5 volts. And then pin 16 we also connect to positive 5 volts as well because it's VCC. Pin 13 will be connected to ground. And then we go ahead and connect pin 8. It will be going to ground right here because it's G and D. And we connect all the other pins, which are called the Q pins, as we have on this chart. So all of these pins right here will be connected to LEDs through 330 ohm resistors. These resistors can be anywhere in between 200 ohms up to 470 ohms. So as you can see, Q1 is right here. So we connect it to LED number 1 right here. And then we go on and we do Q2 and it will be going to LED 2. And so on. So as you can see, it's in order to the LEDs as well. And of course, all these LEDs are going to be connected to ground on their anodes. So then we'll come over here to shift register number 2. Pin 11 on this shift register will be going to pin 10 on the Arduino. And then pin 14 on the shift register will be going to pin 9 on the Arduino. And then the last pin, pin 12 on the shift register number 2, will be going to pin 7 on the Arduino. And so then we go ahead and connect the rest of the connections just like we did with this shift register. And then the buttons right here, they are toggle switches. So basically one side of the toggle switch will be connected to ground. So that's what we do to both of these buttons right here. So this is right here is button 1 for opponent 1, and it will be connected to pin 6 on the Arduino. Then button 2 for opponent 2 will be connected to pin 5 on the Arduino. And so basically that is the circuit. So you can go ahead and connect this up, and I'll go ahead and connect this up now. Okay, so now here is the code for the project. So now the first thing we go ahead and do in this code is we go ahead and define these variables. These variables are going to hold the information on how many times we have pressed the button for our next LED to light up on the LED strip. So next we have a struct. So basically, this is all the stuff we need for a toggle switch. Basically, this is just the pin that is connected to the toggle switch. The current state of the button will be stored in here, and then the previous state of the button will be stored in this variable right here. We also have the last millis to know how long we have been pressing the button to avoid the debounce issue. And in TF, you'll see more how we use this. It's something really small. And in action TF, just saying that if we should take action based on what we have done with the button. So then we go ahead and set up our 2 buttons. Since we have 2 buttons for both our opponents on the game, and we go ahead and do button 1, that is 1 struct, and then button 2. They're basically the same. The only thing that's different is the pin numbers that of course these buttons are connected to. We have pin 6, which is connected to button 1, and pin 5, which is connected to button 2. Then we go ahead and set up another struct. This is for the shift registers. And so basically we just set up latch pin, clock pin, data pin. We put all the pin numbers in these variables. And then we have play bits. This variable is going to be holding how many LEDs need to be turned on the LED strip right here. Here, so we just set up all the pin numbers as first latch pin, clock pin, and a data pin, and then also player bits. Same thing with player 2 as well. It's just different pin numbers because of course both of the shift registers have to be connected to different pins. So now we have these variables right here, and this is basically going to be holding how many LEDs are on the LED strip for each opponent. So this is for opponent 1 and this is for opponent 2. So then we go into the void setup. We just go ahead and set up all these pins to outputs. Then we set the buttons to inputs, a pull up, basically just set up the pull up resistor. So then we go ahead and do a void loop. We go ahead and we need to see the status of the toggle switch. So basically we run the same function as we will look at soon, and we run it 2 times for each of the buttons. Then the first thing we need to do after we get this new data back from these functions, we need to check if any of these functions contain a true value in the action TF variable, because if they do, that means that there has been a full press of pressing the button and letting go. Then we come into this statement and do player 1 num, and then we set it back to false. And we do the exact same thing for button 2. So then we come down here and we have another if statement here. So basically we just go ahead and say player 1 num is equal to 5. So if it's equal to 5, then that means we come into this if statement. And whenever player num is equal to 5, that means we want to light up an LED on the LED strip of that opponent that has those points, because one LED equals 5 points or 5 presses. So basically here we just go ahead and shift all of the on LEDs over. And then we go ahead and say player 1 num is equal to 0, because now we have turned on the LED for those 5 presses, so we need to make it equal to 0 now. And then we just go ahead and increment num LED player 1 to say that now there is one more LED that's lit on the LED display. We do the exact same thing for opponent 2 as well. Then we need to display this information on the LED display after we get it from here. So that's what we do with these functions. Right here, I will show you this function as well in a few minutes. So we just do one for player 1 and the next one for player 2. And then the last part here in this code file, we have the if statement for someone who has 1. So as you can see, first this is for player 1, but we also have the same if statement for player 2. As you can see, we just do num LED player 1 equals 8. So if this is true, that means all the 8 LEDs are on, and so that player has 1. And so we just go ahead and delay 1 second to show all the 8 LEDs they are on. And then we go ahead and reset everything. So we're ready to play again after all the 8 LEDs of the player who won, all their LEDs blink. Then we go ahead and display the data on display on register player 2. This is so that since we have reset all of this, we need to make sure that all the LEDs on player 2 are off, because we don't want them on. We just go ahead and reset them right away. And then we go ahead and run this function winner show. This is just going to blink the 8 LEDs 10 times, and we'll look at this function as well. So here's the function here with called toggle switch. We accept the button struct, and as you can see, it's called my button. So that's the specific struct that's holding all the information for the toggle switch. So the first thing we do is we go ahead and read the button and see what the current information we get from the button, and we put it into a button new. Then we go ahead and compare and see if button new equals 1 and button old is equal to 0. If this is the case, that means we were pressing the button, but now currently we are not. So we will come into the system right when we let go of the button, and we go ahead and collect the time of millis and put it in the last millis function, so we know right when we let go of the button. And then we do button.tf. This basically tells us that we have currently let go of the LED, supposedly, or most likely we have, but we need to check and make sure this is not actually a press, because sometimes there's a bounce issue where we press the button may first go up and down, like turn high and low very quickly, and this could cause issues with the Arduino reading it. So basically what we do is we go ahead and wait 50 milliseconds, and that's why we read the time, so we know how long we need to wait until 50 milliseconds has passed, because we know the time in millis when we press the button. So that's what we do next, is we go ahead and wait, as you can see right here, wait for 50 milliseconds, which should be enough for the bounce issue to pass. And then we check to make sure the button is still not being pressed, which will confirm that we didn't just press the button and that we all have not the bounce issue, but we actually let go of the button. Then we're just going to have the current millis minus the last millis minus the time when we let go of the button, and then it needs to be greater than 50. If it's greater than 50, then we could come into this if statement, and button.tf is equal to true. So we have to come into this if statement to come to this if statement, and all these things have to be true, of course, to come to this statement. If it is, then we're going to say we need to take an action now because we have fully pressed and let go of the button. So that's what we do here. We go ahead and make action tf equal to true, and then we go ahead and make button.tf equal to false because we have done an action now. So now we no longer need to say this is true anymore, we need to make it false. And then we're just going to go ahead and do button old equals button new, because now this information button new is getting old, so we need to make it, put it in here and go ahead and get out of this if statement, come back and read it again. And that's what we do, is just we go ahead and return a button and get out of the function. Next is the function for display on register. Of course, this is the struct for my shift register, and of course this is for player. And as you can see, we just go ahead and put latch pin low, and then we send it the information, the bits right here. As you can see, we send the bits after we give the shift out function the pins that it needs, which is data pin, clock pin, and then how it should send the bits to the shift register. Then we go ahead and put latch pin high again. So the last function is player show. This is basically going to display the show for the player who won. So all we do is we just come into this statement, we make num blinks equals 10. This variable, of course, is holding how many times we will blink all of these LEDs for the player who won. And we're just going to come into this while loop, and we're going to say num blinks not equal to 0. So as long as num blinks is not equal to 0, we will continue looping this while loop. And as you can see right here is we just say player byte is equal to 0. This means all the bits are 0. That LED strip will be off. Then we display that information. We wait 200 milliseconds. Then we go ahead and turn all the LEDs on, which is using 255 because that's the highest bit. That means all the LEDs are on. And we go ahead and display that information. Then we wait 200 milliseconds, and then we go ahead and minus a blink because that is one full blink right here. And after that, we come out of this while loop and we're done. And so basically that is the code. So now we'll go ahead and see our project in action. Alright, so now here is the project. As you can see, we have the blue side for this button right here, these red LEDs over here for this opponent over here. So we go ahead and start clicking them together. As you can see, both the LEDs start turning on. If I start clicking one button quicker than the other, like the blue one, then the blue will win. As you can see, it blinks. I'm going to wait for it to blink, and now it's reset. And so let's now try to click this button more than the blue one. As you can see, it kind of slowly goes up, and red's going a little bit quicker, as you can see. And as you can see, red is 1, and it blinks all the red LEDs. So basically that is the project. If you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you everyone, have a great day. Bye.